In this video, I am going to show you guys how to solve exponential equations. So let's take a look at the first example. So the first example, we have 3 to the k times 3 to the k plus 2 is 3 to the 5k minus 1. So this is an exponential equation. Okay, we're going to solve this for k. And I have a procedure that you can use to solve this equation. So let's take a look at step 1. So the first thing we have to do is use the properties of exponents to simplify each side of the equation. With this given equation, we have to use the exponent property to simplify this. So we're multiplying powers here. So what do we do when we multiply powers? We have to add the exponent. So we're going to keep the same base. So the base stays the same, which is the 3. And then we add the exponent. So here we have k plus 2. Okay, so that's going to be 2k plus 2 is 3 to the 5k minus 1. Step 2 is to rewrite the equation so both sides have the same base. So according to this equation, we don't have to do step 2. If you look at the equation, okay, they both have the same base. So here you have a base 3. And here you have a base 3, so we do not have to rewrite the 3. Step 3 is to drop the bases and set the exponents equals to each other. Okay, so we're going to drop the bases. So we drop the 3 and then drop this 3. Okay, and then we're going to set the exponent equals to each other. So here we have 2k plus 2 is 5k minus 1. Okay, and then we're going to solve for k here to find out what k is. So I'm going to get the k on the same side. So here I'm going to minus 5k, take away 5k. So here I have negative 3k plus 2 is, okay, those are gone. Bring down the negative 1. And then minus 2. Minus 2. So bring down the negative 3k. And these are gone. Equals to negative 3. And then divide by negative 3. Divide by negative 3. We'll cancel negative 3. You're left with k. And then negative 3 over negative 3 is a positive 1. Okay, so k is a positive 1. Next example, we have 27 to the 2x plus 6 is 3 to the 2x. So here is another exponential equation. So here we have to solve for x. So let's take a look at step 1. So first thing we have to do is use the properties of exponent to simplify each side of the equation. So according to this, we do not have to do that. Step 2 is to rewrite the equation so both sides have the same base. So here we have to rewrite to get to the same base, because here you have base 27 and here you have base 3. So we have to get these to the same base. So here 3 is lower than 27. Here, let's think about the number 27. Can we rewrite that with base 3? 3 to what power will give us 27? So 3 to the third power, it's going to give us 27, because 3 times 3 times 3 is 27. And then you have 2x plus 6. And then on the right side, we have 3 to the 2x. Okay, and then we use the property of exponent here, where we distribute the 3 because we're raising power to another power. So we're going to distribute the 3 here. So we're going to have 3 to the 6x plus 18 is 3 to the 2x. Step 3 is to drop the bases and set the exponent equals to each other. So we're going to drop these bases, and then we go 6x plus 18 is 2x. Okay, we're going to solve for x here, so I'm going to get the x on the same side. So take away 6x, take away 6x. Okay, so here's 6x, take away 6x is gone, bring down the 18. So 2 take away 6x is negative 4x, and then divide by negative 4, and then divide this by negative 4. Okay, so we have 18 over negative 4 is what x is. And then we're going to reduce that. Okay, so your greatest common factor is 2. We're going to divide each number by 2. So that's going to give us 9 over negative 2. So here we can rewrite what x is. So x is going to be negative 9 over 2. So here is another exponential equation. 4 to the 3x is 8 to the x minus 1. Okay, so first thing we have to do is use the properties of exponent to simplify each side of the equation. Here we don't have to do that. Okay, step 2 is to rewrite the equation so both sides have the same base. So we got to get base 4 and base 8 to the same base. So how do we do that? Well, 4 is a smaller number. Are we able to rewrite 8 as base 4? If you put 4 to the first power, that's going to give you 4. If you raise 4 to the second power, that's going to give you 16. So we're not going to be able to do that. So here we're going to have to change both bases to the same base. Okay, with 4, I can rewrite 4 with base 2, so I can get both of these numbers to base 2. So 4 would be 2 squared. Okay, and that whole thing is to the 3x. And then 8, that can be rewrite as 2 to the third power, because 2 times 2 times 2 will give you 8. And then here is the same as 2 to the 6x, because you got to multiply these two powers. And then here is 2 to the 3x minus 3. And then step 3 is to drop the bases and set the exponent equals to each other. So we're going to drop these bases, and we're going to set 6x equals to 3x minus 3. And then here we got to solve for x, so I'm going to get the x on the same side. So take away 3x here, take away 3x here. So here I have 3x is, this is gone, and then bring down the negative 3, divide by 3, divide by 3. So x is going to be negative 1. So here I have 9 to the 2x plus 4 times 9 to the 2x is 1 over 81. Step 1 is to use the properties of exponents to simplify each side of the equation. So here I would have to simplify the left side of the equation. So I'm multiplying powers with the same base. So I'm going to keep the base 9, and I'm going to add the exponent. So 2x plus 2x is 4x plus 4 is 1 over 81. Step 2 is to rewrite the equation so both sides have the same base. So I'm going to rewrite with base 9. So here 81 is 9 squared. Okay, so as you can see, you have base 9. So the denominator is base 9. So therefore, you would have to bring it to the top, okay, to have your numerator as base 9. So it's going to look like this now. So 9 to the 4x plus 4 is 9 to the negative 2. So instead of having 2 as the exponent, it's negative 2. Okay, and then step 3 is to drop the bases and set the exponent equals to each other. So we're going to drop the bases and we're going to set the exponent. So 4x plus 4 is negative 2. Okay, we're going to solve for x here. So I would just have to minus 4 minus 4. So 4x is negative 6. Divide by 4. Divide by 4. Okay, so x is going to be negative 6 over 4, which is the same as negative 3 over 2. Okay, so your x here is going to be negative 3 over 2. So the next one, we have 1 over 7 is 49 to the x take away 5 multiply with 7 to the x minus 9. Okay, so step 1 is to use the properties of exponents to simplify each side of the equation. So here we would have to simplify the right hand side of the equal sign. So in order for us to add the exponent here, we got to have the same base. Okay, so here we don't have the same base. So this is base 49, this is base 7. But we can rewrite one of them to the same base. So we can change 49. So here 1 over 7 is 49 can be rewrite as 7 squared. So now you have base 7 to the x take away 5 and then times 7 to the x minus 9. Okay, so here you have 1 over 7 is, so here you're going to have 7 and then distribute the 2 because power to another power, you multiply their exponents. So that would be 2x minus 10 times 7 to the x minus 9. Okay, now you can add their exponents because you're multiplying powers that have the same base. So here we have 1 over 7 is, we keep the base 7 and then we add the exponent. So here I have 2x plus x, that's going to be 3x, and then negative 10 take away 9 is negative 19. Step 2 is to rewrite the equation so both sides have the same base. Okay, so here we got to get both of these to base 7. And I can do that with the 1 over 7. That's 7 to the negative 1. Because here you have 7 to the first power. So when you bring it up to the numerator, the exponent becomes a negative 1. And then equals to 7 to the 3x minus 19. Step 3 is to drop the bases and set the exponent equals to each other. So here we're going to drop the 7 and then set the exponent. Negative 1 is 3x minus 19. And then solve for x. So I have to plus 19 plus 19. So here is 18 is 3x. So 18 equals to 3x. Divide by 3. Divide by 3. So my x is going to be 6. So next one, I have 4 to the 2x times 1 over 16 is 4 to the 6x plus 18. This is another exponential equation, and we're going to solve for x. Okay, step 1 is to use the properties of exponent to simplify each side of the equation. So here we have to simplify the left-hand side of the equal sign. Okay, so I'm multiplying two numbers here. But in order for me to add the exponent, I gotta have the same base. So I have to rewrite 1 over 16 with base 4. I can do that. So 1 over 16 is the same as 4 to the negative 2. Because 1 over 16, we can rewrite that as 1 over 4 squared. And then if we bring it up to the top, it becomes 4 to the negative 2. Is 4 to the 6x plus 18. Okay, now here I can add the exponents because I'm multiplying powers with the same base. So I keep the base and then I add the exponent. So 2x minus 2 is the new exponent. And then here we have 4 to the 6x plus 18. And then step 3 is to drop the bases and set the exponent equals to each other. So we're going to drop the 4. Okay, and then we're going to set the exponent, which is the 2x minus 2 is 6x plus 18. Solve for x. I have to get the x on the same side, so take away 6x and then take away 6x. Okay, so here I have negative 4x minus 2 is, now this is gone, and then 18. And then plus 2 plus 2, so negative 4x is 20. So negative 4x is 20. Divide by negative 4. Divide by negative 4. X is negative 5.